page 5 of functions. So let's take a look at the number 2 here. Consider the function f of x equals 10 minus 4x. Write down the independent variable for this function. Okay, so remember, there's two variables. There's the x and the y, and the x is the independent variable and the y is the dependent variable. In this case, it's obvious because the x is in the parentheses that the independent variable is just simply called x, like it often is, okay? And we can also see that it's here on the right side. Calculate f of 2, okay? And I'm going to show you how to do this without the calculator because it's a pretty easy one, and I'm going to show you how to do it with the calculator, of course. So let me turn the calculator on. And then basically when you see f of 2 here, don't freak out and say f times 2. It means that 2 is going to replace every position of x in your formula. So if it says 10 minus 4x, that means you're going to replace, and when you replace x, replace it with parentheses 2, okay? So 10 minus 4 parentheses 2 is replacing the x. So all I did was I erased the x and I put in parentheses 2 instead, and then I just work it out. So it's 10 minus 4 times 2. 4 times 2 is 8, so it's 10 minus 8, which is just 2, right? So the answer here would be 2. The way you would do that on the calculator, turning on the calculator failed, so let me try to do that again. And then I think the easiest way to do this, because they're probably going to ask you other values too, and maybe they're going to give you a y value, blah, blah, blah. Go into y equals and go ahead and put the function there. Don't do it in the regular calculator screen, because then maybe you're just going to have to do a whole bunch of separate equations, separate expressions, each with different x values. Why not just put everything, put it here, 10 minus 4x here, and then take a look at the table, and the table gives you every single possible integer value of x with its corresponding value of y. So if I want to know what y is when x is 2, which that's what f of 2 is saying. F of 2 is saying, what's the y value when x equals 2? I can see that it's equal to 2 also, right? I just look over at the y column and it says 2, so I know that the answer is 2. So that's another way you can do it with the calculator. Now it asks us to find the y value for x equals negative 1/2. And this is a little bit tricky because you say, oh, I can do this with the table. And then you go back and you try to find negative 1/2 and it's not there, okay? Now, I'm going to show you two ways to do this. The way you can find negative 1/2 here is you put the cursor close to negative 1/2 and then you change the step size. And you know, if you want to like always do the same thing, you could change the step size to 0.1 because that gives you 10 values between each whole number value. But in this case, we know that we're looking for a 0.5, so we'll just do step size 0.5, and now it'll show us negative 1 and negative 0.5 also. And negative 5.5, of course, is negative 1/2. And so you can see that the y value that corresponds to that is 14. Then it says, show that f of 2.5 equals 0. Now, this show that is kind of annoying because looking on the table, we can see that x equals 2.5 does correspond to y equals 0, right? But that is not showing, okay? Showing what they want. Showing basically means algebra. Use algebra to do this. So what you want to do is start with the left side and see if you can get to the right side, okay? So we'll start with f of 2.5. And we are going to replace f with its expression, which is 10 minus 4x, except instead of x, we're going to replace it with parentheses 2.5. And if we do that, we can see it's actually equal to 10 minus 10, because 4 times 2.5, if you do it on your calculator, you find out it's 10. 10 minus 10 is 0. And we're done. Do you see? We just went through the algebra steps to make the left side into the right side. And once you do that, you have done the demonstration, show that. It's kind of a proof, but not a very rigorous one. There is an x for which f of x equals negative 6. Find this value of x. Remember, f of x is synonymous sometimes with y. So basically what they're saying is y is negative 6. What's the x value that goes with that? Well, we have the table, so we could use the table to find it. Oh, I forgot to show you the trace method for finding negative 1. Let me do that. Let's go back to where it says f of negative 1/2. We're going to use the trace method in the graph to find what it would be. So you go to the graph, and the graph is kind of good because it'll show you like every single value. Oh, and this is a good example because f of negative 1/2 would be right there, right? And you can see that the function disappears into the wilderness here. So we do need to maybe adjust the zoom. Let's do zoom fit because that's the easiest way. If that works, then awesome. Zoom fit, I believe, is option 0, but I'm not sure. So let's go down, see if it's option 0. It is. Enter. And then it's going to adjust the y-axis so that we can actually see many x values from negative 10 to 10. Now what I'm going to do is I'm going to ask the calculator, what's the y value that corresponds to x equals negative 1/2? The way I do that, remember, and we did this last unit, we do trace negative 0.5. Enter. And then it tells me that the y value is 12. What? 12? I thought it was 14. Let's go back and look again. Second table. It has to agree. Oh, I wrote 14, but it's 12. Sorry. See? Okay. So that's a way of checking negative 1/2. I can also check 2.5, but checking that the graph is at x equals 2.5 is 0 is not the same thing as showing. But just to show you how to do that, you do to trace 2.5. Enter. And then you can see that y equals 0 at that point. But show that means use algebra. Okay? There is an x for which blah, blah, blah. Okay, so now what we need to do is we need to find on the table, and I'll show you how to do this with the graph too, because it is a superior method. We're going to find the value of x, which makes y equals negative 6. And you can see from the trend here that it looks like it's over here, down here. So I'm going to scroll all the way down to the bottom. And it looks like I'm getting pretty close to negative 6 because the last number showing on the right column is negative 4. So I'm just going to click a few more times past this and scroll down. Oh, there it is. So y equals negative 6 corresponds to x equals 4. Okay, so the x value is 4. How could you do this on the graph? And this is one of the most difficult graphing problems. And I say it's difficult because the first couple times I say it's difficult because it's harder than doing trace. But once you do it a few times, it is easy. Okay, and like I said, there's only about 8 different calculator procedures you need to learn for the whole 2 years. And I give you plenty of opportunities to practice these enough with the bookwork that you should be able to memorize these easily without doing any extra work besides the classwork. Now, that being said, if you don't do all the problems in the problem set, or if you're someone who needs more practice than that, you're going to forget it, and you're not going to know how to use it, okay? And then you're going to do bad. Okay, so how do you do this? So if I want to do this on the graph, I can't do trace because trace, I give it an x value and then it gives me the y value. Like trace 3 will give me the y value at 3. And I don't want to be doing this forever trying to find it, even though I could probably guess it pretty quick. Let me tell you how to do it with the second calc intersect method, because this is a method that's going to work for all the units, including the ones where we do a lot of curves later. So what you do is you go into y equals, and then you put in a second function which is equivalent to your y value. So the y value desired is negative 6. And if I put negative 6 here, you will see that it will draw a red horizontal line at the position y equals negative 6. And so it's basically saying, well, when does the blue function reach the y value of negative 6? And it's this point right here. If we could only figure out what that point is. Oh, remember second calc intersect from last unit? Remember how I said that once we get through the hard work of last unit, then you're going to start really using all these functions that you learned in last unit in every single unit. So remember you hit click enter 3 times. The intersection is 4, negative 6, so it turns out that the x value is 4. Oh, there we go, x equals 4 again. Okay, so is this method necessary in this particular problem? No. Learning this method is necessary and important for future problems? Yes. Okay. All right, number 4. The graph shows a particular function f. Okay, it's a line. Write down the values of f of negative 2 and f of 6. Okay, so there's a couple ways to do this because we have a graph. we could just use the graph and physically do a trace. We do trace -2 on the graph, and then we look to see the y value, and it turns out to be 5, right? We could do the same thing with 6. X equals 6. Oh, it's off the graph. I wonder if they did this on purpose. So we look at x equals 6, and we don't know what the value is, unless we cheat and we extend it a little bit, and then we can see that it's -3. Okay, but they don't show it on the graph, so let's use a calculator. So we'll do y equals, and then we'll clear out our old two functions, and we're going to put our new function here. Oh, wait a second, we don't have a function. You know, this is kind of a theoretical question, because if they say that this shows the function stops here. So I think there's two possible answers that they're looking for. And I didn't look in the back of the book to see what they wanted. But let's say that the domain of the function starts at -2 and ends at 5. Then one valid answer, and this would never be on the IB exam like this because it's too vague. Okay? So one possible answer is -3. The other possible answer is there is no value, right? You could say empty set. There is no value, because you could write a sentence that says there is no y value corresponding to it. Because it looks, they said that this is the definition of the function. The function only goes for these values, and there is no value for x equals 6. So I'm not sure exactly what they want, because it could be two things, okay? All right. If we wanted to figure out what the value is without doing this little guess here, we could write the equation of this line. Okay, how could you write the equation of this line? Thinking back to the last unit, there's a couple options. One is you grab 2 points, and the 2 points I have here are 0, 3 and 3, 0. I could put those into stat edit and do stat calc ln reg, and it would give me the equation of the line. Okay, and the other thing is I could use slope intercept form, and I could say y equals mx plus c, and I could find the slope of this. Also using stat calc ln reg, I could find the slope, and then the y-intercept is 3. Of course, if you're going to do stat calc ln reg, it gives you the equation of the line, so there's no reason to do stat calc ln reg and also analyze the y-intercept. You either kind of do it by hand. I mean, like, remember, stat calc ln reg gives you the equation of the line and it gives you the slope. It doesn't just give you the slope. Okay. All right. So let's do that. Let's do stat calc ln reg using 0, 3 and 3, 0 just to review that process to show that we still need that sometimes. So stat edit, and I'm going to put 3, 0, and then I'm going to put 0, 3, and then I'm going to do stat calc ln reg. And my equation is going to be y equals -x plus 3. Once I have that equation, I can put it into y equals and use table to find different values. So let me try that method of finding f of 6, assuming that f of 6 actually exists. -x plus 3. And I'll do second table. And I'm still in this weird mode where I'm jumping by 0.5s. If I want to change back to jumping by 1s, I'm going to do second table set. And then I'm going to change this to 0, table start to 0, and delta table to 0. Change both to 0. Not 0. Delta table should be 1. Table start should be 0. Or some other integer. Okay, and then I quit. Okay. And then table. Okay, and then I'm going to find the y value for x equals 6 by doing trace 6. Trace 6. Enter. And the answer is -3, like I guessed here. Okay? Find the values of x that satisfy f of x equals 3 and f of x equals 0. So there's a couple ways to do this. Remember, we could look at the table. And remember, if it says f of x equals 3, x is not 3. X is unknown. Y equals 3. So what x value makes y equals 3? 0. So the answer here is 0. And when f of x equals 0, I look again, y equals 0, not x equals 0, and then I see that x equals 3. Okay? And the other way you could find out when f of x equals 3, remember, is the second calc intersect method. And so I would put the function here, and then I would put the value 3 here, and then I would graph it, and it would give me a horizontal red line at x equals 3. And I would do second calc intersect, and it will give me the same answer. Find the set of values of x for which f of x is less than 0. Okay, so that means that it's y is less than 0, which means the height is negative, which means it would be the values over here, right? So what are the values of x which make this which make it less than 0? So that would be these values here, right? And I don't know if it goes on forever or not. I'm guessing it doesn't, but okay. So let's assume that it doesn't go on forever. I think that's slightly harder to answer. So basically what we're going to say is the x values are like 3, 4, 5, 6, blah, 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 or 3, 4, or 5, and all the numbers in between. So we'll do something like this. 3, 4, it goes up to 5. So something like this. This is the set of values for which the heights are negative, right? But the question is, do we put less than or equal to on both of these? And what about this value? Is this value less than 0? Yes, it is. So I agree, let's put less than or equal to 0, less than or equal to 5, because 5 is included in the x values that produce negative y values. But what about this value here? The value where x equals 3. When x equals 3, is the y value negative? It's right on the line, right? It's 0. So technically, x equals 3 does not produce a negative y value. It produces a 0 y value. And since this is less than 0 and not less than or equal to 0, then this should also be less than. It shouldn't include 3 because 3 does not produce a negative y value. Okay? All right. Let's move on. Now, let's say that you wanted to go on forever. If you wanted to go on forever, you would just put that, right? You wouldn't put that x is also less than or equal to 5. Okay, let's move on. Number 5, the number of cells in a culture N, T hours after it has been established, is shown in the graph for 0 is less than or equal to T is less than or equal to 20. And even though this might be hard for you to understand when you read through this, you have a second shot because you can look at the graph and you can pretty much see all this information from the graph, right? N is the y-axis. T is the x-axis. That's part of the information they gave us. Hours. Do you see? It's like they repeat the information in 2 different places. So if you're good at reading it in the paragraph, that's fine. If you're good at seeing it from the graph, that's fine. The problem is if you're not good at either one, then you need to develop that, okay? And probably reading it from the graph is more useful because that's normally what we do in math, right? Okay. As you can see, this is like a biology problem. They're talking about growing cells in, a little petri dish or something. A, the relation represented in the graph is a function. Give reasons why this is the case. Again, when you have a graph and you're trying to prove it's a function, vertical line test, you draw vertical lines in several places, it cuts 0 1 times, not 2 times. That is why it is a function. Okay? So you would say, oh, it's a function. It's a function because vertical line test, cuts 0 1 times, not 2 times. Okay. On an exam, don't just write vertical line test because it doesn't show that you understand what vertical line test is. You need to explain that you drew vertical lines and it only cut the graph maximum of 1 time. B, state the independent variable and the dependent variable. Remember, the independent variable is synonymous with x, dependent variable synonymous with y. In this case, they didn't name them x and y. They named them t and n. So the answers are t and capital N. In math, very important, capital letters and small letters are not the same thing. In the same problem, they could use small t and capital T. In fact, it's often used time is usually small t and temperature is usually capital T. So if you're a person that always writes capital letters, you can't do that in math. It'll mess up your answers, your IA, blogs, everything. I take off points for that. Estimate the initial number of cells in this culture. Okay, so the initial, that's code word for t equals 0, right? The beginning of the experiment. So basically they're saying, what is the y value when t equals 0? What is the n value when t equals 0? Well, t equals 0 is right here, right? And so it looks like it's about, I don't know, 4? A lot of times you're going to have a graph problem like this and you can estimate it from the graph. They don't, you might say, oh, well, if I look in the calculator, I can get a better estimate. Well, you can't put it in the calculator because we don't know what the function is, right? If it's a line, we can often put the line into the calculator because we can look at a graph and figure out the equation of a line by picking out 2 points. But when it's a curve, you can't do that normally. Okay, estimate the value of n when t equals 4. When t equals 4, we're talking about this point right here. If we look to see the y value or the n value at that point, it looks like maybe it's 10. Maybe it's less. I think it's less. Maybe 8. I don't know. I would say 7 or 8 is fine. Estimate the value of t when n equals 32. Ooh, tricky. Now instead of giving us the t value, they're giving us the n value. 32 is about there, so that looks like it's about there. So it looks like it's going to be t equals 12. Estimate the interval of time over which the number of cells varied from 64 to 128. So 64 is about there, and 128 is about there. And so 64 corresponds to that point about there, and 128 corresponds to, I think, the last point here. The graph actually stops there. So it's these 2 points here. What x values does it correspond to? It corresponds to 16 and 20. So the interval of time where the cells varied from 64 to 128 is between 16 and 20. And let's put that in math notation. We'll make an inequality, and we'll put big N in the middle, and then we'll put less than or equal to's in between. Find the range of this function. Okay, so let me just erase some of these things so we can see the curve better. And then I'll use the yellow highlighter to highlight all the values. And this kind of, it looks like it ends here at about 125. It doesn't go up to 128, but we know it goes to 128 because it says 128 here. So kind of misleading. Okay, let's say that the highest value is 128. So the top value is 128, and the bottom value is 0 because the graph starts at 0? Not necessarily. Look at this. The bottom value looks like it's about 4. Oh yeah, 4. It starts at 4. So be careful. The range is not 0 to 128. It is 4 to 128. So I'm going to put 4, and I'm going to put 128, and then I'm going to put the range value, which is n. And then I'm going to put inequalities less than or equal to. In this case, does less than or equal to apply? Is it including these endpoints? I'll say yes. Okay, so less than or equal to. Okay? That's it for this page.